Hello, fourth grade, and welcome to lesson 6-4. We're going to work with more modeling of multi-step problems. So this is a continuation of the lesson we started last time in 6-3. Let's go ahead and watch our short video lesson, and then we're going to jump into our guided practice and our notes for this section.
How can you model and solve multi-step problems? Chef Angela needs 8 cartons of eggs to make the cakes that are ordered. She has 2 cartons of eggs and 4 single eggs in the refrigerator. How many more eggs does she need to make all of the cakes? Chef Angela has 2 cartons of eggs and 4 single eggs. She needs 8 cartons of eggs. Each carton has 12 eggs. She estimates she needs about 6 more cartons, or about 6 times 12, which equals 72 more eggs. One way to solve the problem is to find the number of eggs the chef has and subtract it from the number of eggs she needs. How many eggs does the chef have? The chef has 2 cartons, each with 12 eggs, plus 4 single eggs. 2 times 12 plus 4 equals 24 plus 4, which equals 28. The chef has 28 eggs. How many more eggs does she need? The chef has 28 eggs. Let n equal the number of eggs she needs. Recall that she needs a total of 8 cartons of eggs. You can use the equation n equals 8 times 12 minus 28 to find the number of eggs she needs. What does the expression 8 times 12 represent in the equation? The chef needs 8 cartons total. So, the expression 8 times 12 is how many eggs she needs in all to make the cakes. Solve for n. N equals 96 minus 28, which equals 68. The chef needs 68 more eggs. Since 68 is close to her estimate of 72, the answer is reasonable. Another way to solve the problem is to first find the number of full cartons the chef should buy, then find the number of eggs she needs. The chef needs 8 cartons. She already has 2 cartons, so she should buy 6 full cartons. Out of the 6 cartons, how many eggs does she need? Recall that the chef already has 4 single eggs, so she won't need all of the eggs from the 6 full cartons. Let n equal the number of eggs she needs. Which equation can you use to find the number of eggs she needs?
Select your answer.
You can use the equation n equals 6 times 12 minus 4. How does this equation represent the number of eggs she needs? The expression 6 times 12 is the number of eggs in 6 cartons. The equation shows the number of eggs in 6 cartons minus the 4 eggs she already has. Solve for n. N equals 72 minus 4, which equals 68. The chef needs 68 more eggs. Since 68 is close to her estimate of 72, the answer is reasonable. Now you know how to model and solve a multi-step problem.
All right, now let's go ahead and jump into our notes and our guided practice. Now, the title of our lesson, 6-4, More Model Multi-Step Problems. Now remember, when solving multi-step problems, remember to first find out what information you have, then find out what hidden questions you need to answer. After answering your hidden questions, then solve the problem in the question. you can use equations and bar diagrams to help you see the parts and to solve. Now I've given you an example question here, and you can see that I use two colors, and we're going to understand why in just a moment. 5 toy makers each carved 28 blocks and 17 airplanes. 3 other toy makers each carved the same number of airplanes and twice as many blocks. How many toys did the 8 toy makers carve in all? So for this, I used two colors. My 5 toy makers, I circled their information in orange. The other 3 toy makers, I circled their information in green, and then I answered the question. So over here for the 3 other toy makers, it said they made the same number of airplanes, so also 17. So I wrote the 17 up here so I don't forget. And they made twice as many blocks. So twice as many means 2 times whatever the other group made. So the first group, the 5 toy makers, made 28 blocks. So the 3 other toy makers made 2 times 28 blocks. So I wrote that equation up here. This way, I don't have to reread the entire word problem to find the information that I need. The 5 toy makers made 28 blocks and 17 airplanes. The 3 toy makers made 17 airplanes and 2 times 28 blocks. The question is asking me, how much did the toy makers carve in all? So what do I know? The 5 toy makers each made 28 blocks and 17 airplanes. The 3 toy makers each made twice as many blocks and also 17 airplanes. Now, what is my hidden question or my hidden questions? There's multiple ones. How many blocks did the 5 toy makers make in total? Remember, each one of them made 28. So we want to figure out what was the total number of blocks they made, what was the total number of planes they made. For the other 3 toy makers, how many blocks did they make and how many airplanes did they make? Now I need to stop and think, what steps do I need to follow to solve? So let's think. My 5 toy makers, so there's 5 of them, each made 28 blocks and 17 planes. So 28 plus 17 times 5, because there's 5 groups of them. Each one of those 5 made 28 blocks and 17 planes. So 5 times the sum of 28 and 17, which is saying 5 times 45. So 28 plus 17 gave me 45. So the 5 toy makers made 5 times 45 toys. Now the 3 toy makers, this is where things get a little bit interesting. They made 3 times the 17 planes, which we know, and then 3 times whatever 2 times the 28 blocks was. And we found out that 2 times 28 gave us 56 over here. Now, that's the same thing as saying the 3 times the 17 planes, excuse my mistake right here, plus the 3 times the 56 blocks. So let's go on and see how we're going to solve this. So the 5 toy makers each made 17 planes and 28 blocks, which is the 5 times the 17 plus 28. We said that was 5 times 45 equals however much the 5 made. The 3 toy makers made 17 planes and twice as many blocks. So the 3 times 17 for the planes for the 3 toy makers made 17 blocks each. And then the 3 toy makers each made twice as many, or sorry, these are planes. The 3 toy makers made twice as many blocks as these guys. So 2 times 28, whatever that is, multiply that by 3 because each one of those 3 toy makers made that much. So we found out that 28 times 2 is 56. So the 3 toy makers each made 3 times 17 airplanes and 3 times 56 blocks. So now I'm going to draw my bar diagram. I'm going to use T as my total, the total number of toys. So the total number of toys is 5 times 45, which is how much the 5 toy makers made, plus the 3 times the 17 for the planes that the 3 toy makers made, plus the 3 times the 56 for the blocks that the 3 toy makers made. So 45 times 5 gave me 225, I wrote that in there. 17 times 3 gave me 51, I wrote that in there. And 56 times 3 gave me 168, so I wrote that in there. So my total, T, is equal to 5 times 45 plus 3 times 17 plus 3 times 56, which is the same thing as saying, after I solve these, T is equal to 225 plus 51 plus 168. So I'm going to start adding these together. 251 plus 51 gave me 276, plus 168 gave me 444. So my answer is that they made 444 toys in all. Now again, there were a lot of steps here, so we're going to go back through them to make sure that you got all of the steps. So we figured out the information from the question. 5 toy makers each made 28 blocks and 17 planes. 3 toy makers each made twice as many blocks and also made 17 planes. So I have to figure out how many blocks were made, how many planes were made by the 5, and then how many blocks were made by the 3, and how many planes were made by the 3. So what I did was I took, actually we'll go on to this side, my 5 toy makers. I took the information I knew from them. They made 17 plus 28 toys in all, and there were 5 of them. So 5 times the sum of 28 plus 17, or 5 times the sum of 45, because when you added 28 to 17, you get 45. The 3 toy makers each made 17 planes, so 3 times the 17 for the planes that they made. And the 3 toy makers each made twice as many blocks as these guys, so 2 times the 28. So that gave us 3 times 17 for the planes plus 3 times 56. That's what we got when we multiplied the 28 times 2. Now I drew a bar diagram. My total number of toys was the 5 toy makers toys altogether, plus the 3 toy makers planes, plus the 3 toy makers blocks, which when I write it as an equation is the same thing as saying T, my total, is equal to 545 plus the 317, or sorry, 3 times 17 plus the 3 times 56. When I solved each one of those, 5 times 45 was 225, 3 times 17 was 51, and 3 times 56 was 168. Now I need to add all of these partial numbers to find my total. So 225 plus 51 gave me 276, 276 plus 168 gave me 444. So they made a total of 444 toys in all, between all 8 of those toy makers. Now let's take a look at another example. It says a company has 2 geothermal plants that power a total of 2,034 homes. After they build 3 more powerful plants, they can now power a total of 5,799 homes. How many homes does each of the new plant power? Explain, use equations and bar diagrams to solve, and tell what your variables represent. So we have a lot of information here. So we know that the first 2 geothermal plants could heat or warm up a total of 2,034 homes. We know that after they built 3 more, so now they have a total of 5 geothermal plants. After they built those 3 more plants and now have a total of 5 geothermal plants, they're able to power or heat 5,799 homes. Now our question is asking us, how many homes does each of the new power plants power? Explain our thinking, use equations and bar diagrams, and tell our variables. So we know, let's take this one step at a time. We know 3 times n. I'm going to make n my new power plants. 3 times n is equal to the 3 power plants, the 3 new plants' homes. So 3 times n is equal to 5,799 minus the 2,034 that were powered by the original 2 plants. So the total number of homes that were being powered minus the homes that were powered by the 2 original ones. When I subtract those numbers, I get a difference of 3,765. So that means all 3 of those new power plants can power a total of 3,765 homes. So the way I draw that as a bar diagram, my 5,799 homes was my total. My 2,034 homes was the original part that I know from the question. And then 3 times the new power plants equals 3,765, which was the difference that I got here. Now, 3,765 is how much all three were powering. So now 3,765 is my total, and I need to divide it between all three of the new power plants to figure out how much one power plant powers. So I'm going to use N. N is going to equal how much one new power plant, how many homes one new power plant powers. So N is going to be equal to my 3,765 divided between the three power plants. Now I can do this using long division, or I can write an equation. I'm going to do both. So N is going to equal 3,765 divided by 3. Now, if I do long division, there's 3,000s that go into 3,765. So I put my 1 over here in the thousands place, and I subtract off 3,000. Now I'm left with 765. Now that I'm working in the hundreds place, there's 300s that go into 765. So 3 times 200 is 600. That leaves me with 165 as my difference here. Now I'm working in the tens place. So 3 times 50 will give me 150 because 3 times 5 is 15. 3 goes into 165 50 times. So 165 minus 150 left me with 15. And 3 goes into 15 5 times. I subtract off the 15 and I'm left with no remainder here. So once I finish my division, I can see that one of the power plants can power 1,255 homes. And that's going to be my N. N is equal to 1,255. So one new power plant can power 1,255 homes. So let's go back and take a look at the steps that we followed in this question. I annotated my question. I knew that 2 geothermal power plants power 2,034 homes. The 3 new ones that are more powerful, all together, plus the 2 that came before it, powered 5,799 homes. How many homes did one of those new power plants power? So I knew that 3 times the new power plants was equal to 5,799, the total number of homes, minus the original number of homes, which gave me 3,765. So all 3 of those new power plants could power a total of 3,765 homes. So 3 times N was equal to 3,765. Now the total number of homes, to do this subtraction as a bar diagram, I can draw it out as 5,799 is my total, 2,034 is the part that I know, and then 3 times N, all 3 of those new power plants, is over here. And I found out that was 3,765. Now, because I know that's 3 of my N's, I need to figure out what one of my N's is. So I need to figure out what one of those power plants can power. So my 3,765, I needed to divide it between all 3 of those new power plants. So in order to do that, I wrote an equation. N is equal to 3,765 divided by 3. I drew my bar diagram, and then I proceeded to do my long division. And I found out that 3 goes into 3,765 1,255 times. So each one of those new power plants could power 1,255 new homes. So my N was equal to 1,255. Now we're going to go ahead and jump into our guided practice for this lesson. I know this lesson had a lot of information, and our multi-step problems are becoming a little more complex. But if you're following and keeping with the same steps that we learned originally, where you identify what you know and write it down, figure out what the hidden questions are, figure out how to solve those hidden questions, and then use those answers to answer the main question in the question, you can answer any multi-step problem. Now for number 1, it says explain the meaning of the expression 2 times 12 plus 4 in the problem that was on the previous page. So this is the question about the egg cartons. So 2 times 12 represents 2 cartons of eggs that each have 1 dozen eggs or 12 eggs in them. And the 4 represented the 4 extra eggs that she already had in her fridge, in addition to those 2 cartons. So she had 2 complete cartons plus 4 extra individual eggs. in the problem on the previous page, how many eggs will the chef have left over? So if she needed 68 more eggs and she bought 72. Because she's buying full cartons of eggs at the time, and she already had 2 full cartons plus 4 extra, the extra that she's going to have are those 4 because she needed 8 complete cartons to bake, and she had 2, so she bought 6 more, but those 4 extra eggs were extra leftover eggs that she wasn't going to need. So our remainder here is going to be 4. The extra amount that's going to be left over is 4. And for our last guided practice question, it says Carrie's stamp book has 20 pages. Each page can hold 15 stamps. She has 45 international stamps and 4 times as many US stamps. Can all her stamps fit in her book? Use the bar diagram below to solve the problem. Draw other bar diagrams as needed and show the equations that you used to solve. So I annotated my question. I know that she has 20 pages in her stamp book. I know that each page can hold 15 stamps. I know she has 45 international stamps and 4 times as many as the 45 of the US stamps. We want to know, can all of them fit in her book? So I'm going to use U to represent the US stamps. So I know that she has 4 times as many as the international. So U is going to equal 4 times 45. So I'm going to draw the bar diagram with U up here, the number of international stamps right there, and 4 groups of 45. So now I know she has a total of 180 US stamps plus the 45 international stamps. So 180 plus 45 is going to equal T, my total number of stamps. Now I'm going to use B to equal the stamps that her book can hold. So B is going to equal the 20 pages of her book times 15, which equals 300 stamps. So I know her book can hold 300 stamps on all 20 of those pages. So I know right away, since she only has 225 stamps and her book can hold 13, that yes, all the stamps can fit. She has 225 stamps and her book can hold 300 stamps. So 300 is greater than 225. So all of her stamps are going to fit. Now that takes us to the end of this lesson. If you guys have any questions, please let me know. Otherwise, I hope you have an amazing day. Take care. Bye-bye.